Module 1, Lesson 10 is a continuation of Lesson 9, where we're going to use ratio tables to solve ratio problems. The objective of this lesson is that you're able to identify the additive and the multiplicative structure of a ratio table. Feel free to pause at this point in order to copy down the notes on the table below. Once you have finished, hit play as I will explain what each piece means. For this ratio table, it's a B to S, and the ratio original one is the 10 to 30. I then created equivalent ratios below by skip counting by my original number, 10, 20, 30, 40, 30, 60, 90, 120. You also could use a multiple as long as you do the same to both sides in order to create the next number. So for this one, I took a 10 times 2 to give me 20, 30 times 2 to give me 60, and then a 10 times 3 to give me 30, and a 30 times 3 to give me 90. A 10 times 4 to give me 40, and a 30 times 4 to give me 120. Each of these being equivalent ratios on the ratio table. The two pieces that you need to now identify is the additive, and the additive is just simply that number that we're adding every time, and it's always going to be the same. So we have a 30 plus 30 to give me 60, a 60 plus 30 to give me 90, and a 90 plus 30 to give me 120. Which demonstrates that we were skip counting by the first number. On the left side, we started with the 10, and so the number we were skip counting by was 10, which is repeatedly adding 10 each time. 10 plus 10 gave me 20, 20 plus 10 gave me 30, 30 plus 10 gave me 40. The multiplicative is the number that gives the relationship between the first number in our ratio and the second number in our ratio. The first number in this ratio is a 10, and the second number is a 30. So a 10 times 3 gave me 30. As long as that number is the same all the way down, that's what we would call the multiplicative. 10 times 30 is 30, 20 times 3 is 60, 30 times 3 is 90, and 40 times 3 is 120. Therefore, the multiplicative is 3. If you look down below, I wanted to demonstrate, since we've been talking about value and equivalent ratios, I wanted to show how I could prove that these are equivalent to each other using the values. So the first ratio of 10 to 30 has the fraction of 10 thirtieths. 10 and 30 have the greatest common factor of 10. So I took 10 divided by 10 and got a 1, and a 30 divided by 10 and got a 3. I have a 20 to 60. Therefore, the fraction or the value is 20 sixtieths. The greatest common factor between 20 and 60 is 20. 20 divided by 20 is 1. 60 divided by 20 is 3. My next ratio's value is 30 90ths. 30 and 90 share the greatest common factor of 30. 30 divided by 30 is 1. 90 divided by 30 is 3. And my last ratio was 40 to 120. Their greatest common factor is 40. 40 divided by 40 is 1, and 120 divided by 40 is 3, giving me 1/3 for each ratio, which means they all share the value of 1/3 and therefore are equivalent to each other.